Alright, can I have a volunteer to read example 1 for me? Alright, Crystal, go ahead.
Suppose you two entering arithmetic and Einstein and read the following concept. The problem is determining the order they will perform. The problem is to determine the order of performance based on a random selection. The one plan is written on one of 5 cards. The card is placed in a hat and the 5 cards are drawn one at a time. The order of performance is based on the order in which cards are drawn. What is the probability of rolling stones between the fourth and the middle?
Okay, so this is a permutation problem, and what do we remember about permutations? Order matters. Just like a concert, it matters what order they go in, right? So for this specific problem, they tell us that they want the Rolling Stones performing fourth. Go ahead and underline that. And they want the Beatles to perform last. How many bands are there in total? 5. Okay. So the probability, the formula we're going to use are number of successes, like usual, over total number of options. Jesus, will you turn the light out closest to the trash can? Thank you. So number of successes, and in this case the successes would be Rolling Stones performing fourth and Beatles last. That's what we want to happen. And then the total number of options will be in any order. So what I want you to do is draw 5 blanks on top and 5 on bottom. Why did I pick 5? There's 5 bands, right? Options or choices. Alright, so say if they all 5 are in a hat and that we are not worried about the Rolling Stones performing fourth and Beatles last. Okay, so they're all in a hat, all 5 of their bands. So for this first spot, how many options would I have to pick from? 5, right? All 5 names. The first one I pick will be out of those 5. Okay, so say if the one I picked was U2. Then how many bands do I have left in the hat? 4 to pick from, right? And the next one would be 3, 2, and 1. Good. So on bottom is 5. What's that word? Factorial. Good. Now let's talk about what's on top, because on bottom is just the number of options. On top, we want to change it to the number of successes. So in this 4th spot right here, how many bands do we want performing right there? 1. One specific one, right? We want the Rolling Stones to have that spot. Nobody else. And what about the last spot? 1, right? We want that one band to be in the 5th spot. So if we take those bands and make them perform 4th and 5th, how many bands do we have left if we have chosen a spot for them? 3, right? So we could choose any 3 for the first one. We're not worried about the first spot. For the second one, it'd be how many left? And the next one? 1. Good. So now to get the probability, we just multiply the tops together. So 3 times 2 times 1 times 1 would be what?
6.
And do y'all remember how to find 5 factorial in your calculators? Yeah. If you don't, just raise your hand. I'll come help you. It'd be what now? Good. Okay, I'll come help. Go ahead and turn it into a percentage in your own. So you get 5, 11. Anybody else need help with their calculator? Hit. Yours is like above the 3. So hit 5 first. The second button. And then Alright, so, well, first of all, let's go ahead and simplify this. What is a number that goes into 6 and 120? 6. Do y'all know what I mean when I say, like, what's a number that can go into both of them? Mm-hmm. One person tell me what it means. Yes, divided into both numbers evenly, right? So what's the number that can go into 6 and 20? How many times up top? 1. And on bottom? 20. Good. So what is the percentage? 5% chance. Good. And how did y'all find the percentage?
Divided and multiplied by 100.
Great job.
Do you have to reduce it?
Yes. I want you to reduce it for me. And because this is why I do it. I wouldn't care if you left it 6 over 120, but on the ACT, do you think they'll have the answer choices as 6 over 120 or 1 over 20? 1 over 20. So you'll have to know that those are the same. Okay. Any questions about that one? All right, let's look at the next one. So, Alandria, if you'll read example 2 for me.
Find the probability of U2 performing first, the Rolling Stones performing fourth, and the Beatles performing last.
All right. So, will our denominator change in this one? We still have the same number of bands, right? So our bottom will be 120. Same number from here. And then on top, let's go ahead and draw our 5 blanks. All right, did they give us specifics about who's going to perform first? Yes. How many bands will perform first? Just one, and it's U2. One specific band. What about in the 4th spot? Good, and they want the Beatles last, so that'll be... So if those 3 bands are out, we've decided where they're going to go. We'd have 2 left, right? So it'd be 2 and then 1. Good. Yes. How'd you get 1 over 60? Perfect. And when I want you to give me the percentage. Go ahead and round it to the nearest percent. Y'all know what I mean by that? 2. Good, just like the whole number. 2% chance. I'll tell you when to round it to the nearest percent and tenth or hundredth. So just to review, and this might seem silly to y'all, but I'm going to do it anyways. Go all the way up to the top. Write the number 2.5823. And I want you to write nearest percent. And I'll give you time to copy this down. Nearest tenth. Nearest hundredth. And I won't ask you for any other 3 than this. So on your quiz tomorrow, I'll either say round to the nearest percent, round to the nearest tenth, round to the nearest hundredth. And I want you to know the difference between each one, but using the same number. So if I said round this to the nearest percent, it would be what?
3.
Good. This 5 is going to round this up, so it'd be 3%. That's to the nearest percent. If I said round to the nearest tenth, that's this place, right? And this does what? Moves it up, so it'd be 2.6%. Nearest hundredth would be 2.58%. Good. This 2 does not round this 8 up. Does that make sense? Yes? Okay.
Yes, ma'am.
All right. Anybody want to read example 3 for me? Nobody? Okay. Lyric, go ahead.
6 stand-up comics A, B, C, D, and E, F are to perform on a single evening at a comedy club. The order of the performance is determined by random selection. Find the probability that.
Okay, so these specific means that order matters. Okay, they're giving us a certain order. Also, it's a comedy club performers. The order they go in matters, right? So this is a permutation. For the first one, how many comics are there?
6.
So what do you think is going to go in our denominator?
6.
6.
Okay.
6 factorial. Good. Just like up here was what? 5 factorial, right? Alright, now let's draw 6 blanks. 1, 2, 3, 4, 5, 6. So there's 6 opening spots. And the only thing they gave us is that they want E to go first. So in the first slot we need what? Okay, so if comic E is to perform first, definitely. How many other comics do we have?
5.
So it'd be
5, 4,
good.
2, 1.
Perfect. Yeah, but the reason this is because Kennedy, if comic E performs first, it's just like he's not even there anymore. So how many do we have left? 4, 5. So say if we put comic B here, out of those 5, we cross him out. Then there's 4, then there's 3, then there's 2, then there's 1.
This one.
Yes.
We don't have to like cancel it 5, 5, or 6.
Oh, you could. You could. You're saying like, could we cancel out 5, 4, 3, 2, 1? Yes. Absolutely. So let me write this out, like she's saying. 6, 5, 4, 3, 2, 1. All these would cancel out, right? That's the easier way of simplifying it. And so you would have what? 1 over 6, which is what? How much percentage?
Over 20, but less than 30.
Round to the nearest percent.
17.
Good.
So would we not put 120 over 720 then do that?
You could, but which one's easier? Putting 120 over 720 and simplifying that way, or doing it this way?
That way.
Yeah. Good job, Millennium. How we got 1 over 6? Did you know how we got the top and bottom, right? So from here, notice how there's a 5 on top and bottom. What's 5 divided by 5? 1, right? So we can just cancel them out. We can cancel the 4's out because 4 divided by 4 is
1.
3 divided by 3, 2 divided by 2, and then 1. So on top we'll have just 1, and on bottom we'll have just 6. Does that make more sense? Okay. Any other questions about that one? Okay. Alright, next one, it says comic C will perform 5th and comic B last. Does that change the number of options we would have?
Yes.
No, still same denominator, 6 factorial. And let's go ahead and write that out, actually, sorry. 6, 5, 4, 3, 2, 1, so we can cancel them out if we need to. Alright, now on top with our 6 spaces, let's go ahead and take care of this section. Comic C will perform 5th. So in the 5th spot, we would have how many? Just 1. 1, 2, 3, 4, 5. And it says comic B will perform last. So we'll have 1 in this place. Alright, how many comics do we have in total?
6.
6, but we take away these 2, we have
So we have 4.
4.
3. 2. 1.
Good.
Can we just cancel out 4, 3, 2, and 1?
Correct. We can cancel out the 4's.
What are we rounding?
Let's do this one to the nearest percent also. So cancel out the 4's, 3's, 2's, 1's. So it'd be 1 over,
30.
which is round to the nearest percent. 3. Good. 3%. Awesome. Nobody noticed that, Millennia, in my first period class, and we were having to simplify like huge fractions. Good job. And then I showed them the shortcut and they were mad. Alright, next one. Comedians will perform in this following order: D, E, C, A, B, F. On bottom, what will we have?
6, 5, 4, 3, 2.
Good. On top, now let's draw our 6 blanks. 2, 3, 4, 5, 6. They would. In the first spot, how many are it's supposed to perform?
1.
Just this one, right? Then the next one, they give us specific orders that E is to go next. So it'd be what?
1.
It'd be all 1.
It would be. Because they're giving us a specific order that all of them have to go in. No other comic but F can go here. No other comic but B can go here. A here, C here, E, and D.
So it'd be 1 over 720.
Correct. And give me the percent to the nearest hundredth.
Would it be 0.14?
1/4. Good. That's to the nearest hundred. See how tiny that chance is? That they'll go in that specific order? There's only a 0.14% chance. Any questions on that one? Alright, last one's kind of tricky, so stay with me. Comic A or comic B will perform first. Does the bottom change?
No.
No. Alright, draw 6 blanks.
You have a 2 in the first.
The 2 would be first one because you would have 2 different options, right?
Then 2.
Well, hold on. How many, okay, even though we have two options right here, how many can actually perform right there? One, right? One at a time? So if we take one out of those 6 comics, we would have how many left?
5,
And then?
4,
3, 2, 1.
Good. I'll say that one more time. Comic A or comic B will go first, so there was 2 different comics that could go here. But only really comic A or comic B could go here, not both, right? So if comic A was selected to go here, we would have how many different ones left? 5, then 4, then 3, then 2, then 1. Does that make sense?
Okay, so you saying that because it said comment A or B, therefore we had to put 2 down instead of 1.
Yes.
Okay, so since we put 2 down, it's not just, we don't go like 1, 2, 3, 4, 5, and we took up 2 spaces and 1.
This is just the number of options, not how many are performing at that time.
Okay.
Can we mark out 5,
So would it be 2 over 6?
You would mark out 5, 4, 3, 2, 1. So you'd have 2 over 6, which is the same thing as. And the percentage to the nearest percent?
33%.
Good. Perfect. It's not. Any questions about that one? Alright, flip it. Now we're going to talk about the lottery for just a second. And this is real life, a real life situation. Alright, John, if you'll read example 3 for me.
Florida's lottery game, Lotto, is set up so that each player chooses 6 different numbers from 1 to 53. If the 6 numbers chosen match the 6 numbers drawn randomly, the player wins or shares the top cash prize. For one Lotto ticket, what is the probability of winning this prize?
Okay, so we're just buying one ticket, and we're going to see what our chances are of winning the lottery with one ticket. Okay, so there's 6 different numbers, right? Let's write 6 different blanks. 1, 2, 3, 4, 5, 6. First of all, is this a combination or permutation problem? Combination. Well, y'all saw it because the paper, but why do you think it's combination?
It doesn't have to be in any order.
Good. The order that you pick the numbers in the lottery thing, it doesn't matter, right? They don't have to be smallest to greatest or least to greatest. They can be any random numbers 1 through 53, right? So on top, sorry, don't put letters. It's going to be the number of successes. So number of successes of you winning the lottery over the total number of options. Same thing as last time, same formula. Number of successes over the total number of options. Do y'all remember the formula for a combination problem? No?
N factorial over N minus R. Factorial. R. Factorial.
Perfect. Go ahead and write that down because I know y'all didn't remember. That is the combination formula. We are going to have to use it, or you can use the combination button in your calculator. So this is when order doesn't matter.
Oh, we're doing this.
It's not hard. Alright, with one lottery ticket. So Armando goes to Florida and buys a lottery ticket. Just one. How many chances does he have to win if he buys one lottery ticket? One, yeah. If he buys 10 lottery tickets, he has 10 chances of winning, right? But when he buys only one, he only has that one chance of winning, right? Okay, so that's going to be our numerator. He has one chance because he bought one lottery ticket. And now we're going to figure out how many different lottery tickets there would be with numbers 1 through 53 with 6 numbers. So we're going to have to use this formula. What would be our N in this formula if we're talking about the different numbers? Yeah, there's 53 different numbers. And how many, there's 53 numbers you can fill into how many spots? Good. Go ahead and figure out what 53C6 is in your calculator. I will help you if you don't, yeah, hold that. If you can't remember how to do it. Yeah. Hold it there. Good.
It's 3, 2, 4.
I think you need a permutation button.
I used to see that. I got 22 minutes, 5 cents.
Alright, everybody know how to calculate it in your calculator? You got it, Hayden? Okay. Alright, then one person, Alandry, tell me the number.
22, 957, and 480.
Good. Did everybody else get this number? If you did not, just raise your hand. I'll come show you how to do it in your calculator. Do you know what this fraction means before we find the percentage? That Armando. Oh, you couldn't find it.
How was supposed to find the percentage?
It's this thing right here. So get 53 second. And then that would be
Cause I don't know what ain't got your calculator.
Alright, what this fraction means before we turn it into a percentage is that Armando, if he went to Florida and played the lotto game and he bought one ticket, he would have 1 in 22,957,480 chances of winning. Do you know how tiny that is? If you didn't know how tiny it was, try to type this in your calculator. 1 divided by this number, and then times it by 100. Did some of y'all say e to the negative 4th power or negative 6?
Yeah.
Yeah, it should, because this is how the number looks, and I want you to write this down. 0.123. That's how tiny the percentage is of you winning the lottery with one ticket. That is insane. Yes.
So what if it does it like my calculator did it, where it's 4.3558? Yeah,
And it had,
and inside it's X 10 negative 6.
yeah, that means that there's 6 zeros and then that number. The 6 to the 6th power is those 6 zeros. Okay?
Okay, so like, why wouldn't we just put like 0.0 and you know that line on top?
They're repeating.
Yeah, the line on top and then where it's 36.
That's only if like it was like 1.333333. You could put 1.3 repeating. These zeros only repeat to right here, so we couldn't put that. Has to be repeating like forever.
Okay.
So if you're thinking about buying a lottery ticket,
You can't buy one again.
if you only buy one, that's your chances of winning. Now I need a volunteer. Tim, how many lottery tickets in this game do you think you would buy to have a good chance of winning? Just name out something. Okay, so 2,000 tickets. If you bought 2,000 lottery tickets, let me show you your chances of winning. 2,000 divided by the same denominator. Look at your percentage.
So it's still close enough.
It's still not even
A percent.
past 0%. Even if you bought 2,000 lottery tickets. It just depends.
I mean, you would have to buy 2 million.
Not that many, but
So what if you did $1 million?
What if you did 6,000?
you can find it on your own. We got to move on. Okay. Paige, if you'll read example 4 for me.
A club consists of 5 men and 7 women. 3 members are selected at random to attend a conference. Find the probability that this group consists of 3 men.
Alright, so does order matter here?
Yeah. No.
They're just going to a conference. Doesn't matter what order they go in, right? They're all going to the same place. And they have 5 men and 7 women. So how many is that in total? 12 people, right? So I'm going to put N equals 12. And how many are selected to go? 3, right? So that's going to be our denominator. And this is why. They're picking, out of 12, they're picking 3 people. So all of our possibilities would be calculated by 12C3. Okay, 220. That's all of our possibilities. Now we got to look at our numerator. It says find the probability, so here's our success. Find the probability that the selected group consists of 3 men. That's our success. That's what we're trying to put on top. Okay, so how many men are there in total?
5.
That will be our N in this one. Out of how many do we want selected?
3.
Good. So what is 5C3?
10.
Good. What is a number that can go into 10 and 220?
10.
How many times on top
1.
and on bottom? Good. Give me the percent rounded to the nearest tenth. Good. And to find the percentage, you just do 1 divided by 22, hit enter, and then times 100. So there's a 4.5% chance that the 3 people that they select out of the whole entire group will be all men. Alright, same numbers. We're just now going to find the probability that the club consists of 1 man and 2 women. So in this one, our success was just talking about 1 gender, right? Just men. Now our success is talking about 1 man and 2 women, so 2 different genders. Will that change our denominator? Still have the same possibilities, right? They're still picking 3 people out of 12. This time, instead of having 3 men, we just want to select 1 man. It's still out of how many?
5.
Good, so it'd be 5C.
2. 1.
Good, because we only want 1 man. Times, since there's 2 genders, we'll have 2 combinations up top. And we want to select 2 women out of how many? 7. Good, so it'd be 7C2. Alright, so one person tell me what 5C1 would be. Okay. What about 7C2? Whenever y'all get it, you can just say it out loud. Somebody said it? 21? 21? Okay. You talk so quiet. And what is 12C3? We found that one from last problem. It'll still be 220. What's 5 times 21? Alright. What's the number that can go into 105 and 220? Good. How many times can 5 go into 105?
21.
And into 220? Good. Give me the percent as rounded to the nearest tenth. 47 point what now? Good. So that's a much better chance if it was going to be a man. You did 100. 2 more. Do y'all think y'all could do example 6 on your own? Why? It's not hard.
This right here?
The combination you think's harder?
Just the,
Okay.
this is a little,
Alright, fine. I will do 6 and 7 together.
Oh, what is trust?
You can go ahead and work ahead on your own. Okay. Camille, if you'll read example 6 for me.
A group consists of 4 men and 5 women. 3 people are selected to attend a conference. Find the probability that the selected group will consist of all women.
Alright, so let's start with our denominator first. It'd be 9C.
4.
Where?
5.
That's what's going to go on top, our number of successes, right? This is what's going to go on top. On bottom is going to be 9 because that's the total people, right? How many are being selected? 3 out of 9. Now we can talk about our successes so that the group will be all women.
so it'll be 9 and 5.
Close. How many women are there in total?
5.
And we want to select
3.
Very good. Does that make sense? Or do I need to go over that one more time? Okay. So on bottom, it'll always be the total number of options. So that'll be 5 plus 4 in this case, 9. and it says out of these 9, 3 people will be selected. So 3 out of 9 will be our total options. And then it says the group will be all women. So we look, how many women do we have in total? 5. And out of that, we want to have 3 selected. So what is our numerator going to be?
10.
Out of
24.
what goes into both? What goes into both? 2. How many times 2 go into 10? And into 84? Good. Give me the percentage as the nearest percent. 12%. Good. Nearest percent, that just means like round it to the nearest whole number. Alright, next one's kind of tricky. Any questions about this one before we move on? Okay. Alright, the next one, anybody want to read that one for me? Alyssa, go ahead.
3 men and 3 women line up at the checkout counter at Walmart. Find the probability that the first person in line is a woman, and the line alternates by gender.
Okay. Think about this question. Do you think that it's going to be combination or permutation? Think about it. Permutation. I put that on purpose so you could think about it. I said this was tricky. This one is permutation, but can somebody tell me why? Order does matter. And how do we know that order matters in this one? Yes, the first person has to be a woman, so that order matters. And then it alternates by gender. So their order does matter in this one because they're given a specific thing that we have to follow. Okay, so in this one, first of all, let's go ahead and draw. I cannot draw people, so I'm going to put an M for a male and an F for a female. So here we go. Here's my 3 males and 3 females. Alright, so it'll be the total number of successes. And what would be our success? Not a number, just what would be our success in this problem? A woman going first, and what else? Alternate by gender, right? Underline this. This is our success. That's what's going to go on top. But on bottom is going to be our total number of outcomes, right? That's a S, success. On bottom is going to be all the options. How many people are there in total? Straw or blanks. Not permutation. I know what you're trying to say. Factorial. Good. Because if there are 6 people right here, how many of them could go first in the checkout line? 6 of them. Any 6 of them could go first, right? Say if this was Martha. Martha could go first if she wanted to, or it could be Frank. Okay? Any of them could go first, whichever one gets there. And then after, say if Martha went, how many people were left to go next? 5. And then 4, then 3, then 2, then 1. That's our total number of options. Alright, now on top. The first person in line has to be a woman. Okay, so we can cover up all of these F's. Or excuse me, all the M's. All of these are males. So there's 3 females that we can choose from, right? So in the first blank it would be 3. Say if this little female went first, we can mark her out. The next person in line has to be a what? A male. So how many males do we have? 3. Alright, say if Mr. Frank went, so we mark him out. Then it would be 2, and then 2, and then 1, 1. Sorry, I draw too many blanks. Does that make sense?
So is it 3 factorial?
No, it's not 3 factorial. Let's mark out the ones we can, okay? So this is 1, 3 we can mark out. This is a 2 we can mark out. Here's a 1 we can mark out. So on top would be 3 times 2 times 1. And that is 3 factorial. Is that what you're asking? Okay, yes. And on bottom, 6 times 5 times 4 would give us what?
20.
What goes into 6 and 120? Hold on.
6, 2.
What is 6 times 5 times 4? Okay, that's how we got it. No, because remember the 3's we canceled out.
It'll be 112. So 6 goes 6 one time, and then 6 goes 120 12 times.
All right, so 6 goes into 6 how many times?
1 time,
And into 120?
12.
20.
I mean,
Okay. I thought so, but, I don't have a calculator up here, so.
because 6 times, hold on.
6 goes in the middle.
Yeah, 6 times 20 is 120. Give me the percent chance.
5.
5%. Awesome. Alright. No, you don't have to. Remember that if you complete this sheet I'm about to hand out, and it's only 7 questions, you can use these notes, your 11.4 notes, and the sheet on your quiz tomorrow. But if you don't complete these 7 questions, you won't get to use nothing.
We got to complete it.
You don't have to do it tonight, or you have to do it tonight. You don't have to do it in class.
Oh.
This is due tomorrow. Tomorrow I'll be checking it. Also tomorrow. I will be checking your bell ringers. You should have 7 tomorrow. You should have 6 right now. Okay? And this is your only homework this week, so this is all I'll be checking. What now? Yes.
Hello.